Could tiny black hole atoms be elusive dark matter? So this is an article from space.com. It's an old article, but it is very interesting, and I thought to make a video about this. So, what is actually dark matter? According to scientists, dark matter is the mysterious, invisible stuff that makes up the most of our universe, and it has to exist because there is nothing, not enough visible matter in this universe which could account for all the gravity that could bind all the galaxies together. So there has to be something which is producing all that gravity which could bind all the galaxies and other large scale structures together. So dark matter is that invisible and mysterious stuff, and till now we have not actually detected any dark matter in the universe. And now a group of Russian astrophysicists have claimed that actually dark matter could be tiny black holes, quantum black holes in the universe, and we just cannot detect these black holes because of the intrinsic property that they cannot emit light and they cannot reflect any light. All the light that enters the black hole is absorbed. All the information is destroyed inside a black hole, so it's very hard to detect these black holes. And a group of Russian astrophysicists at the Institute for Nuclear Research of the Russian Academy of Sciences in Moscow are suggesting this idea. So the concept is not entirely new. According to this article, a lot of other scientists have suggested this very idea that miniature black holes could make up dark matter. And physicists have long believed that microscopic black holes must have existed in the early universe. Early universe means before Big Bang, I think. So before Big Bang, when only quantum fluctuations were going on in the universe, at that time microscopic black holes could have existed because quantum fluctuations in the density of matter just after the Big Bang would have created regions of space dense enough to allow the formation of such tiny black holes. So early universe is not before the Big Bang. Sorry for that. It is just after the Big Bang, and that period of time is called actually early universe. So actually I got confused because there is a theory that Big Bang itself started because of quantum fluctuations, and I would make a video on that also, or that too, later. So the idea is that due to quantum fluctuations, Big Bang was created. So I think this could be that article. Yes, the Big Bang wasn't the beginning after all. So I will make a video on this later, but let's get back to the article. So what they are saying is that quantum fluctuations in the density of matter just after the Big Bang would have created regions of space dense enough to allow the formation of such tiny black holes. Enigmatic Friedmans. The new study by Tukuchev and Yorshenko suggests these are the scientists who are proposing this idea, the Russian scientists. So they are suggesting, this study suggests that a specific type of quantum black hole might exist, so-called black hole atoms. These microscopic black hole would originally have an electric charge. This charge would have attracted protons or electrons, leaving the tiny black hole electrically neutral, just like an atom. Okay, so the black hole would originally have an electric charge. This idea is partly based on the Friedman theory proposed in the 1970s by prominent Russian physicist Moisey Markov and Valery Frolov of the University of Alberta in Canada. Okay, so this Friedman theory also was proposed by a group of Russian physicists. So Russian scientists are really taking the lead in this kind of research, I guess. A Friedman is a mathematical solution of the Einstein field equations, which are key constituents of the theory of general relativity. To an external observer, a Friedman looks like a micro black hole with an electric charge the same as that of an electron. Okay. However, the Friedman's interiors can be microscopically large, up to the size of the known universe. Frolov, who was not involved in the new study, told space.com. Okay, so this is a very interesting idea that to an external observer, a Friedman looks like a micro black hole with an electric charge, and but its interior can be macroscopically large, up to the size of the known universe. Wow, that is like the TARDIS in Doctor Who, which is bigger from the inside. I guess if you have seen Doctor Who, you will get what I'm saying. Markov and Frolov never made the link between the Friedman and dark matter, but Dukushev says that such neutral black hole atoms should have the same properties that dark matter is thought to possess. Okay, so these tiny atoms of dark matter could account for the huge gravity which we are detecting, but we cannot detect the source of that gravity. So these mysterious dark matter atoms could account for that gravity. The black holes would have about the same mass as an asteroid, but be even smaller than atoms. Their interaction with ordinary matter would also be extremely weak, even weaker than that of neutrinos. So neutrinos are the particles which pass right through the Earth, and there are a lot, I think billions and billions, I think, of neutrinos that pass right through the Earth and through everybody on Earth, including you and me, per second. Let me do a quick search on that. How many neutrinos pass through the Earth? And as you can see, 65 billion neutrinos pass through just 1 square centimeter of the Earth every second. Holy crap, that is a lot of particles, and they are so they don't interact with anything, and they just pass right through everything. And almost all of them pass right on through the Earth and out the other side. That is interesting in itself. So what they are saying, back to the article, that they do not interact. These black hole atoms are like neutrinos, and even their interaction is even weaker than that of neutrinos. The quantum black holes would therefore be dark, massive, non-interacting particles with properties that one need for dark matter candidates. Elusive dark matter. But Frolov doesn't think that the idea quite works. Using Friedman's for the explanation of dark matter looks contradictory. Dark matter must be formed of WIMPs, weakly interacting massive particles, while Friedman's atoms participate in the electromagnetic interaction. So there are some doubts on this theory. Possibly for this reason, Dr. Dukushe proposed to put an electron orbit inside the Friedmann. However, in this case, the Friedmann configuration will not be stabilized by an electric charge, and its external mass may be reduced to zero value. Frolov added, another unsolved problem of this model is the mechanism of Friedmann's formulation. One can expect that in order to produce a sufficient number of Friedmanns to explain the dark matter in the early universe, there must exist large, small-scale inhomogeneities. This is difficult to explain in the standard inflation models. Other cosmologists also have doubts. Usually, black holes are not expected to be charged in astrophysical or cosmological environments because they quickly get neutralized by accreting charged particles of opposite sign, electrons or protons, from their environment. So I think they're referring to the Hawking radiation, I guess, because that is what it is, that the black hole accrete charged particles of opposite sign. I'm not sure about that though. But Dukushev is, I'm just looking at the image, but Dukushev is convinced that his concept is just as good as all the other dark matter theories. After all, no one has yet spotted this mysterious invisible stuff. So let me read the rest of this article. Black hole atoms now join a long list of candidates for dark matter particles, from supersymmetric neutralinos to WIMPs and axions to warm sterile neutrinos and many more. Verifying whether any of them is the real deal will require catching one first and then examining them, I guess, and spotting a neutral black hole atom should be possible, because the formation of these peculiar invisible objects might produce a detectable signal. When an electron is drawn into a quantum black hole so that a black hole atom is formed, the process would release energy in the form of a flash of ultra-high energy cosmic rays. Also, electron jumps from one level to another would release photons, making black hole atoms. So this is an interesting article, and basically what they're saying is that the dark matter could be explained by the existence of these miniature quantum black hole atoms, but there are a lot of reservations about this theory. One is that it is not really stable, because if we put an electron around its orbit, the entire atom will not be neutral, and there are some other doubts, like black holes are not expected to be charged because they quickly get neutralized by accreting charged particles, so it's not possible that they are charged, so they cannot have electron orbiting around them. So this was an interesting article, and tell me in the comments what topics I should cover, and see you in the next science video.